Hello friends, myself R.D. Mahajan presenting my video on Engineering Mathematics 2 Unit 3rd Linear Differential Equation with Constant Coefficient Part 1 Revision Part 1. First example, solve d square minus 3d plus 2 into y is equal to e raised to 3x. This is the second order linear differential equation with y as a dependent variable and x as independent variable, and this stands for operator d by dx. Auxiliary equation is d square minus 3d plus 2 is equals to 0. Finding the factors of this, uh, factors are d minus 2 and d minus 1 is equals to 0, such that product of these two is plus 2 and sum of these two term is minus 3. Then equating each to 0, we get d is equals to 1 and d is equals to 2. Here roots are real and different. Roots are real and different. And as the roots are real and different, complementary function Cf is given by C1 e raised to m1x, that value is 1, therefore C1 e raised to x plus C2 e raised to 2x. We call this as equation 1. First part of that solution. Then in second part we find pi, that is particular integral, as by inverse operator technique 1 upon d square minus 3d plus 2, which we have to operate on e raised to 3x. This is the first case for pi, e raised to ax type of term, and whenever we have such type of term, rule is that d we have to replace by a is here coefficient of x, therefore d replaced by 3. We get 1 upon 3 square 9, 3 2s are 6 and plus 2 into e raised to 3x, and therefore we get 9 plus 2 11, 11 minus 6, we get 1 by 5 as into e raised to 3x, and we call this equation 2, that is pi. Then complete solution is given by Cf plus pi. Question is asked for 6 marks. Then the scheme of marking. For getting the Cf, you will get 2 marks. For finding pi correctly, another 2 marks. And for the last solution, 2 marks, 6. Or sometimes it may be like this: 3 marks for this pi and 1 mark for this last answer. Total 6 marks. This is the scheme of marking. Approximately, not exact. It may vary by 1 or 2%. Therefore, 2 plus 3, 5, 5 plus 1, we get 6 marks. Second example, solve linear differential equation d square minus 2d plus 1 into y is equal to x e raised to x into sine of x. And therefore, here auxiliary equation is, and once again for 6 marks, auxiliary equation is d square minus 2d plus 1 equals to 0. It is a perfect square of d minus 1 whole square equal to 0. Means there are two factors, d minus 1 and d minus 1. Equating each to 0, we get d is equals to 1 and d is equals to 1. Here roots are real and repeated. Roots are real and repeated. Second case for Cf, and therefore complementary function is c1 plus c2x multiplied by e raised to x, and we call this equation 1. For the steps up to this, you will get 2 marks. Means finding the roots and then writing the CF. Then particular integral is 1 upon d square minus 2d plus 1, which we have to operate on x e raised to x sin x. There are 3 terms. Therefore, we rewrite that 3 terms as e raised to x multiplied by x into sin of x. Means I have converted this in the case e raised to x into v, where v is x sin x. And for this case, rule is that we have to replace d by d plus a. A is here coefficient of x, that is 1. Therefore, replacing d by d plus 1, we get, and while writing it, e raised to x we have to take before the operator, 1 upon, replacing d by d plus 1, we get d plus 1 whole square minus 2 times d plus 1 and plus 1, which we have to operate on x sin of x. Simplifying it by expanding this first term, its expansion is d square plus 2d plus 1 a square plus twice ab plus b square. Then minus 2d minus 2 and plus 1, which we have to operate on x sin of x. Simplifying it further, we get e raised to x 1 upon. This d square remains as it is. Plus 2d cancel with minus 2d. Plus 1 plus 1, 2, 2 minus 2 get cancelled. Therefore, only d square, which we have to operate on x sin of x. 1 by d square, if d stands for d by dx operator, 1 by d is integration operator, and therefore splitting this 1 by d square as e raised to x 1 by d and again 1 by d. 1 by d means integration of x sin of x with respect to x. Therefore, it is e raised to x 1 by d times, integrating this by generalized part, x first term as it is algebraic and sin x as second term as it is trigonometric term. Therefore, as per that integration by generalized part, first term x, integration of sin minus cos x then minus derivative of first term x 1, next integration of cos sin with this minus sign, therefore it is minus sin of x. Next term 0, derivative of that constant term 1, and then simplifying it, it is e raised to x 1 by d means once again integration of minus minus, it becomes sin x and minus x cos x, and then its integration with respect to x. It is equals to e raised to x as it is, no change. Integrating these two terms independently, integration of sin is minus cos of x minus integration of sin x is minus cos x, and then integrating this x cos x by generalized part, first term x, integration of cos sin x, then minus derivative of x is 1, next integration of sin is minus cos x, . and x becomes 0. And then simplifying it, we get minus cos x, and this minus cos x, we get minus 2 cos of x and minus x sine of x. We call this equation 2, pi. Then complete solution is CF plus pi. It is always for dependent variable. Therefore, y is equal to CF. CF is C1 plus C2x multiplied by e raised to x, and plus, or here we can take minus and common. Therefore, minus e raised to x, x sin x plus 2 cos x as required answer. For pi, 2 marks or 3 marks, and 1 mark for the last step, total 6 marks. And then exactly on the same line, try to solve next example by yourself. D square minus 2d plus 1 into y is equal to x e raised to x into cos of x. Another example. Therefore, do it yourself. Right hand side term is x e raised to x into cos of x. Third example, solve linear differential equation d raised to 6 minus d raised to 4 into y is equal to x square. If you see the right hand side term, it is of the type x raised to m. Then first finding the CF, auxiliary equation is d raised to 6 minus d raised to 4 is equals to 0. Taking d raised to 4 common, we get d square minus 1 is equals to 0. Equating each to 0, we get d raised to 4 equals to 0 and d square minus 1 is equals to 0. D raised to 4 equal to 0, it gives you 4 values for d: 0, 0, 0 and 0. And d square minus 1 equal to 0, this gives you d square equal to 1, means d equals to plus minus 1. Therefore, total 6 roots. First 4 roots are real and different, real and repeated. Therefore, it is C1 plus C2x plus C3 x square plus C4 x cube. And for this next two, we get next constant C5 e raised to minus x and C6 e raised to x, and we call this equation 1. Once again, 1 mark for obtaining the roots and 1 mark for this. Therefore, 2 marks for this first 2 steps. Then pi by inverse operator technique, d raised to 6 minus d raised to 4 operated on x square. As it is of x raised to m type, we apply the technique where we have to take the lowest degree term as a common. Degree of first term is 6, degree of second term is 4. Therefore, taking that, we take minus d raised to 4 common. Therefore, 1 and minus d square. We get plus d raised to 6, which we have to operate on x square. Then this is minus 1 by d raised to 4. Transferring this to numerator, it becomes 1 minus d square raised to minus 1 operating on x square. Then expanding it by binomial theorem up to terms containing d square. Therefore, expanding by binomial theorem. Expanding by binomial theorem. Its expansion is 1 minus capital X has to minus 1. Expansion is 1 plus x. X is here, d square. Next, square of d square is d raised to 4. And so on. Which we have to operate on x square. Then, minus 1 by d raised to 4, neglecting d cube and higher order derivative. Therefore, considering only first two terms, that is 1 plus d square, which we have to operate on x square, we get minus 1 by d raised to 4. 1 into x square, we get x square. Second order derivative of x square. First derivative is 2x, next one is 2. Therefore, it is minus 1 by d raised to 4 operated on x square plus 2. Then 1 by d stands for integration. Therefore, integrating this 4 times with respect to x. Splitting that d raised to 4 as 1 by d cube into integration of x square plus 2. It is minus 1 by d cube. Integrating this term, we get integration of x square is x cube by 3. Integration of 2 is 2x. Then again splitting this d cube as minus 1 by d square and integration of this term. It is x cube by 3 plus 2x and its integration with respect to x. Therefore, minus 1 by d square. Integration of x cube is x raised to 4 by 4 and previous 3. 4 3s are 12 plus integration of 2x is 2 times x square by 2. Then it is equals to, again splitting this 1 by d square as 1 by d into 1 by d means minus 1 by d integration of this term x raised to 4 by 12 and plus x square. Its integration with respect to x. It is minus 1 by d means the integration of integrating this with respect to x. Next integration is x raised to 5 by 5 and 5 12 is 60 plus integration of x square is x cube by 3 and then its integration with respect to x, last time integration. Therefore, minus x raised to 6 by 6 into 6. 6 6 is 36, therefore it is 360 and plus integration of x cube is x raised to 4 by 4, 4 3 is 12. We call this equation 2. If you perform this step correctly, step by step, you will get that 2-3 marks for this. Means 1 mark, another 1 mark and last 1 mark, 3 marks. And then finally, complete solution is CF plus PI. Therefore, Complete solution is for the dependent variable y. CF is this one, equation 1. Therefore, it is C1 plus C2x plus C3x square C4 x cube plus this two term, that is C5 e raised to minus x plus C6 e raised to x, and this minus x raised to 6 by 360 and plus x raised to 4 by 12. This is the required answer. 1 mark for this step. Total 6 marks. Example number 4. Solve d2y by dx square plus 6dy by dx plus 9y is equal to 5 raised to x minus log 2. There are two terms on the right hand side, means we have to find out pi1 and pi2. Given differential equation is not in the symbolic form, therefore first step we convert it into symbolic form using capital D for the operator d by dx. We get d square plus 6 times d plus 9 operated on y, and that is equal to 5 raised to x minus log 2. Then auxiliary equation is d square plus 6d plus 9 equal to 0. It is perfect square of d plus 3 whole square. It is d plus 3 whole square equal to 0. If we expand it, we get once again the same term. And then equating each term to 0, we get d is equals to minus 3 and again minus 3. Here roots are real and repeated. And as roots are real and repeated, complementary function is c1 plus c2x e raised to minus 3x. We call this equation 1. For this step, we will get 2 marks. 1 mark for finding the roots and 1 mark for the CF. Then pi 1 upon d square plus 6d plus 9, which we have to operate on 5 raised to x. First term. This is not under any shortcut form, therefore we have to rewrite that term as e raised to log of 5 raised to x. E and log it cancel, we get original 5 raised to x. Then it is 1 upon d square plus 6d plus 9. As per the laws of logarithm, this power we can take as x log of 5. M log n nothing but log n raised to m as per that property. And then it is converted in the first case e raised to x type, where we have to replace d by a. A is here the coefficient of x, that is log 5. So replacing d by log 5, we get 1 upon log 5 square plus 6 times log 5 and plus 9 operated on this term. This is nothing but 5 raised to x. Therefore, once again we substitute it as original form 5 raised to x, and we call this equation 2. Then we try to find out pi. 1 upon Pi2 is equal to 1 upon d square plus 6d plus 9, which we have to operate on log 2. Log 2 is constant term. Therefore, whenever we have any constant term, we convert it as multiplying it by e raised to 0x. E raised to 0, 1. 1 into that log 2, we get original log 2. And therefore, a log 2 we can take outside. And 1 upon d square plus 6d plus 9, which we have to operate on e raised to 0x. And as per that case, d is replaced by a. A is here 0. Therefore, replacing d by 0, we get log 2 1 upon 0, 0 plus 9, therefore 1 by 9. And e raised to 0 is 1. And therefore, we get that Pi2 as log 2 divided by 9. Equation number 3. Then combine that equation 1, 2, 3 to get the complete solution. Therefore, complete solution is CF plus Pi. Complete solution is always for dependent variable. Here dependent variable is y. CF is C1 plus C2x multiplied by e raised to minus 3x plus Pi1 1 upon log 5 square plus 6 times log 5 plus 9 into 5 raised to x, and Pi2 just way of 10, therefore it is with minus sign, log 2 by 9. Required answer. Therefore, for this CF part, we get 2 marks. You get 2 marks. And for Pi1 and Pi2, for Pi1, 2 marks. For Pi2, 1 mark. Total 3 marks. And 1 mark for the last step. Total 6 marks. This is the distribution of marks. Last example number 5. Solve differential equation d2y by dx square minus 2 times dy by dx plus plus 5y is equal to 25x square. The term on the right hand side is of the type x raised to m. Therefore, first step, converting it in terms of symbolic form. In symbolic form, it is d square minus 2d plus 5 into y is equal to 25x square, where that capital D stands for the operator d by dx. Then auxiliary equation is d square minus 2d plus 5 equal to 0. Here real factors are not possible. Therefore, applying the formula minus b, minus of minus 2 we get plus 2, plus minus root of b square minus 2 square 4, minus 4 times ac, a1 and c is 5, and divided by 2a, 2 into 1. Simplifying it, we get 2 by 2, that is 1, plus minus root of 4 minus 20. 4 minus 20 we will get root of minus 16 and by 2. It is nothing but 1 plus minus square root of 16 is 4. Therefore, 4 by 2 we get 2 and root of minus 1 is I. Therefore, we get such type of pair of imaginary roots, alpha plus minus I beta. Roots are imaginary. And as the roots are imaginary, applying that case to write down CF, CF is given by e raised to alpha x, e raised to 1 times x, means e raised to x, into C1 cos of beta x plus C2 sin of beta x we call this for this steps you will get 2 marks. 1 mark for finding the roots and 1 mark for writing the CF. Then the PI part, by inverse operator technique, it is d square minus 2d plus 5, which we have to operate on 25 x square. 25 constant term we take outside. Taking the lowest degree term common from all this. Here the lowest degree term is 5. Taking 5 common and writing the term from right to left direction. Remaining terms are 1. Second term is minus 2 by 5d and plus d square by 5, which we have to operate on x square. 25 by 5 we get 5, 1 upon. This is 1 minus. Taking minus in common, we get the first term as 2 by 5d and minus d square by 5. Which we have to operate on x square. Then transferring this to numerator, we get 5, 1 minus 2 by 5d minus d square by 5 whole raised to minus 1 operated on x square. Then expanding this by binomial theorem, terms containing terms up to d square. Therefore, expanding we get 5 times 1 minus 1 plus x. X is here 2 by 5d minus d square by 5. Then square of it. It is 2 by 5d minus d square by 5 and its square and so on, which we have to operate on x square. This bracket raised to 1, its expansion remains the same. Therefore, 5 times 1 plus 2 by 5d and minus d square by 5. Then a minus b whole square, expanding by that a minus b whole square formula, and consider the terms up to d square only. Therefore, the a square means 4 by 25 d square twice ab. D into d square, it becomes d cube. Therefore, neglecting that d cube term. And b square means square of this d square. It is d raised to 4. Neglecting that term also. And therefore, from this term, we consider only first term, that is 4 by 25 times d square. And which we have to operate on x square. It is 5 times 1 into x square, we get x square plus 2 by 5 d of x square means derivative of x square. Derivative of x square is 2x, first derivative, minus 1 by 5 second order derivative of x square. First one is 2x, next one is 2. Therefore, into 2 plus 4 by 25 d square of x square. Again, second order derivative of x square, that is 2. Applying it, we get 5 times x square 2 to the 4x by 5 minus 2 by 5 and 8 by 25. Simplifying it further, x square no change. I will keep that 4 by 5x also as it is. And finding the LCM of 5 and 25. LCM is 25. 8 minus 5 5 is 25 and 5 to the 10, therefore minus 10. We get 5 times x square plus 4 by 5x, 8 minus 10, we get minus 2 by 25. We call this as equation number 2 as PI. Therefore, for getting this PI correctly, you will get 3 marks. And the last step is complete solution. CF plus PI. For adding equation 1 and 2, we get dependent variable is y, therefore the solution is for y. CF is e raised to x, C1 cos of 2x plus C2 sin of 2x and plus 5 times x square plus 4 by 5x and minus 2 by 25 as the required answer. And for this last step, 1 mark. Total 6 marks. 2 marks for CF, 3 marks for PI and 1 mark for the final solution. Sum of all this is 6. Therefore, generally problem of this type is asked for 6 marks. In this video, I have discussed 5 different problems from the previous question paper. If you like my video, please share it as well as subscribe to my channel, and to receive the notification for my new videos, you have to press the bell icon. Thank you. Thanks for watching.